Hello, everybody. Welcome to the webinar. Today, we'll discuss how you can simply and seamlessly set up secure file transfers to Amazon S3 over SFTP and other protocols. I'm Smita Sriram, Product Manager in AWS, and I'm joined today by Jeff Bartley, who's a Solution Architect for AWS Transfer Family. A little bit rundown of the agenda today. We'll go over the service overview. I'll talk about a little bit about some of the use cases and benefits of using the service. I'm also excited to do a little deep dive into some of our recent launches. Jeff's going to give you a demo of the service. We'll wrap it up with a recap of what we discussed today and leave some time for Q&A from the audience. So why do you have the need for file transfers? Where do you use file transfers today? Some examples are third-party file transfers where you need to receive or exchange files with some of your third parties like vendors, your suppliers, other research organizations you're interacting with. Right? Those are some of the examples where third-party file exchange are used in some of your workflows. The other example is you might be producing value-added data that you want to securely share with other organizations, and they may be some of these might be your end customers who you want to share data with. The other example that we've seen are internal applications that are either running in your on-prem environment or inside your VPC, and you want to access that data stored in Amazon S3 from some of these applications. And in order to do that, some of the challenges that you encounter while setting up these file transfer systems are, you need to manage your own servers, manage storage, keep tabs on how much storage is growing in your environment, and keep adding compute and storage. The other aspect is monitoring for reliability, uptime, and availability, making sure the system can scale in real time to meet your file transfer needs. And the third and most important one is security and maintenance, that ongoing patching, maintenance of your systems, and then making sure it's in compliance with the necessary certifications, especially when you operate in a regulatory environment. And that's why we introduced the service AWS Transfer Family back in November 2018 at re:Invent. You're probably running some of these file transfer infrastructure today inside your VPC or in an on-prem data center, right? And now with moving over to the service, you pretty much can eliminate that infrastructure that you're running on your own. And now your end users' file transfers can be stored in Amazon S3. And now, because you can integrate existing identity management systems, as far as your end users are concerned, this migration was completely seamless because there were no changes to their credentials, no firewall changes, no scripts. So a huge portion of how they interacted with you remains unchanged as you made this migration to the cloud. And now with the data in S3, it opens up numerous opportunities for you to modernize some of that downstream processing so that you have what I have on the slide are just examples of AWS services that you can use with this data. So going over a little bit into the benefits that the service offers to you. The first one is it's a fully managed service, and what that means, it's highly available across up to 3 AZs at any given time. The service scales on demand, so based on real-time traffic, how much traffic you're receiving from your end users, the service scales to meet their needs, which means that we can support thousands and thousands of concurrent users as they access your data over any of these protocols. The next one is seamless migration, and we'll go into some more details into some of the features that support seamless migration, notably importing your own host keys. And that's important because your server's identity remains the same as far as your end users are concerned. If you're using FTPS, you can import your own TLS certificates. The other one is you can bring your own IP addresses and host names so that your users continue to connect to the same endpoint IP and can use the same host name from their clients. You can integrate your existing authentication systems that store your end users' credentials to keep that same credentials the same as far as your end users. The third one is security and compliance, right? The service provides a few features that supports making it secure and compliant for your file transfers. The first one is IP address filtering, so that you can select which users which users can access your data from which IP address, source IPs. The other one is support for VPC endpoints. So if you have file transfers that need to be strictly run within your VPC, you have that level of control over where that traffic can traverse. And the service is compliant with SOC 1, 2, and 3, PCI, it's HIPAA eligible, and has FISMA compliance. And now with the service being a native AWS service for file transfers, it's natively integrated with a few other AWS services. Notably, the data is stored in its native format in Amazon S3. You can use native encryption, methods like SSE S3 server-side encryption or server-side KMS encryption. The other thing is you get access to auditing and logging via Amazon CloudTrail and CloudWatch, so that any API call, whether it's the service API call, S3 API call, all of that can be accessed within CloudTrail and CloudWatch. Here are some examples of some of the customers who have been successful in migrating to the service. So let's go over a few recent launches. So since earlier this year, here's a rundown of some of the launches. Notably, earlier this year, we added support for FTPS and FTP. In the remaining slides, I'll go over in detail on some of the features behind these launches. AWS Transfer Family is available in 16 AWS regions today, commercial regions. I'd like to speak a little bit about support for FTP and FTPS. The protocol FTP, we recommend that you use it for non-sensitive data or data that's already encrypted on the wire before it leaves the client side. FTP is only supported within your VPC, so using the service, you cannot make any endpoint publicly accessible or internet-facing if clear text FTP is enabled on it. In order for FTP to work, you need to use the custom authenticator, which means that you need to integrate an existing identity management system so that you can use username and passwords for FTP access. Only passive mode is supported, and we recommend as best practice that you use different set of credentials between FTP and more secure protocols like FTPS and SFTP. A little bit about FTPS. The use cases where FTPS is used or where data needs to be encrypted, so regulated workloads, or you might want to integrate your CRM or ERP applications that cannot use SFTP today. Now, FTPS is supported on internet-facing endpoints, as well as if you want to restrict FTPS only within your VPC. Again, FTPS also requires that you integrate an identity management system using a custom authenticator. Passive mode is the mode supported, and you can bring your own ACM certificate. So either you select a certificate from ACM, or you can import a certificate from an external provider into ACM and then select it for use within our service. Only explicit mode of FTPS is supported. So overall, you can enable all three protocols on the same server as long as the conditions are met for what the protocols require. Some of the example applications that use these protocols are, for example, in the automotive industry, dealer management platforms may only have the access to use FTP. In manufacturing, some of the device integrations are done via FTPS and FTP. If you're in the financial services industry and want to add yet more data acquisition methods beyond SFTP, you now have more choices so that you can increase your data provider access. Or if you want to distribute data, you now have even more options to offer to your subscribers when they want to use your data. M&E content management platforms, many times some of these content management platforms might be running on legacy systems that only support FTP, or in many cases when you upgrade them, you could even use encrypted FTPS. If you operate in the utilities industry, as part of your supply chain workflow, many of your vendors might only use FTP or FTPS, and this gives you a way to modernize some of that data workflows so that the data is now in S3. Moving on to the next launch, source IP authentication. So earlier this year, we added a feature where in addition to your user's password username, we also now make their source IP available as part of the authenticator. So now when your users log into the service, we tell you what the credentials they use, that's the username and password, the protocol that they used to log in, as well as the source IP of their client. Now, what you can do with this information is you can apply fine-grained access controls based on the IP address. So you can allow, deny access, or even limit access based on the IP address that they're using to access your data. Another feature that we added was increasing traceability of your data access in logs and events. So to give you a little context, when your users log in, we use an IAM role that you supply to access your S3 bucket to service when we need to service their file transfers. We log that IAM role information into many places that you can use in some of your downstream workflows. For example, that information now shows up in your S3 events, Amazon CloudWatch logs, as well as CloudTrail logs. So, if you want to track, who's accessing that data and what role they're using, it's available to you in S3 access logs, CloudTrail logging if you're using object level logging, as well as Amazon S3 event notifications. I'm also pleased to announce support for security policies. Again, backing up to give you a little context, when your end users log in using their clients, they offer up a few algorithms, encryption algorithms that the client is capable of using to negotiate the connections. As a server, we select the most secure algorithm from the list that were presented in from your clients. Now with this launch, you can control what algorithms can be used to negotiate that connection. The security policies that we support are the default one that we support today. In addition, you can select to not use any SHA-1 algorithms when negotiating that connection. So now when your clients negotiate, we only select algorithms that are SHA-1 to establish that connection. The third type of policies are FIPS-only algorithms. So you have the option to only negotiate algorithms that have been noted as FIPS compliant. We also expanded support for what you can use as usernames. So now with this launch, you can now use characters, the @ symbol and dot symbol as usernames, which means now as usernames, in addition to alphanumeric, hyphens and underscores, you're now able to use @ and the dot symbol. We also increased the username limit from 32 to 100 characters. So what that means for you is now you can use email addresses as logins. Right, so you might have a vendor or a supplier who's using an email address to log into any other system that you've provided them access to, and this gives you a way of keeping the credentials the same between these different systems and the file transfer interactions. The other one is you might want to use directory domains as part of the username, so that depending on the directory domain that's appended to the username, you get a chance. You're able to now limit access, deny access, or control access based on that extra piece of information you get from the user in their username. With that, I'll hand it over to Jeff for a demo of the service.
Well, thanks, Smitha. Great to be with all of you today. My name is Jeff Bartley. Again, I'm a solutions architect on the AWS Transfer Family team. And what I want to show you today is how easy it is to get set up and going with AWS Transfer Family to do file transfers to S3 using common protocols such as SFTP, FTP, and FTPS, all the stuff that Smith has alluded to so far. So to get started, I've got my laptop. I've got CyberDuck, which is a common SFTP client running on my laptop. And I've set up my AWS environment. So I've got my S3 bucket, and in my bucket, I've created 3 folders for James, John, and then a folder called temp. And then what I want to do is I'm going to set up AWS Transfer Family so that I can copy data into those folders. And specifically what I'm going to do is I'm going to create 2 users, James and John. Now, James is going to have access to his folder, James. When he logs in, he is only going to see the content of that particular folder. He's not going to see the other folders. Now, John, on the other hand, I want him to have a little bit different experience. When John logs in, I want him to see the John folder and I want him to see the temp folder, but I don't want him to see the James folder. So I'm going to show you how you can accomplish these 2 different ways of seeing data in S3 using AWS Transfer Family. Now, as Smitha mentioned, we have different ways of providing access to our data, and I'm going to use a VPC endpoint today. It's going to be available through the internet, so I can get access from my laptop. And within there, I have 2 subnets that are routed through my internet gateway, so I have public access. And then I'll be accessing the AWS Transfer Family server through a VPC endpoint that the service will create at the time that my server is created. And then finally, I'll show you, we'll use elastic IP addresses to access those VPC endpoints. And then I'll show you how you can use a security group to configure access, which clients can access your actual AWS transfer server. So with that, let's go ahead and get going. And I'm going to jump over to my AWS console. And you can see I'm looking at my S3 bucket that's already been created. So it's called JBNCal Demo Bucket. I'm in Northern California region. And you can see in there, I've got my 3 folders pre-created, James, John, and temp. And what I'm going to do is I'm going to jump over to AWS Transfer, and I'm going to go ahead and I'm going to start creating my server. So I click on Create Server, and you can see that I'm presented with different options for different protocols here. So as Smitha mentioned, we offer 3 protocols today, SFTP, FTPS, and FTP. Now, for my demo, I'm going to stick with SFTP, which is one of the most common protocols out there today. But if I wanted to, I could create a server that uses multiple protocols simultaneously. But in this case, I'm just going to go ahead and I'm going to stick with SFTP, and I'm going to click the next button. Okay, now my next choice is to choose which identity provider I want to go with. And the identity provider is going to dictate how my users authenticate with the server. And we have 2 types of identity providers, service managed and then a custom identity provider. Smith is going to talk a little bit more about these in depth in a few minutes, but for right now, I'm just going to go ahead and choose service managed, which means I'm going to create and manage my users within the service itself. I'll go ahead and click next. And then I'm going to choose an endpoint configuration. So we offer 2 types of endpoints. They can either be publicly accessible, which means they're available over the internet, or we can use one that's hosted from within my VPC within AWS. Now, the great thing about VPC hosted servers is that they offer a lot of flexibility in how you connect, how you lock them down potentially for as far as access goes. And so I'm going to show you a VPC hosted endpoint. And when I choose VPC hosted, I have 2 options for how I'm going to make it available to my vendors, third parties, etc. The first is internal, so I may potentially have the need for a transfer server that's only available within my VPC endpoint. I might use this if I'm only running services within AWS, or if I have a direct connect between my on-premises environment and AWS and I want to lock all access to my transfer server within my VPC. But in my case, I need to open it up today so I have access from my laptop. So I'm going to choose internet facing. And you can see then that I get an option for the host name. Now, there's 3 options here. The first is that I could use a Route 53 DNS alias that I may have pre-configured. I could also provide another DNS name that I've got, and we provide this for you for seamless migration of your existing servers into AWS. Now, in my case, I don't have a host name that I want to use, so I'm just going to let the service auto-generate one for me. The next thing is I need to select my VPC. Now, prior to the demo, I went ahead and I created a VPC within my Northern California region, and it's this one here. Now, if you'll notice, I want to use my VPC, but it's not going to let me choose it because it says no address allocation IDs are currently available. I selected internet facing, and what that means is that I need some publicly accessible IP addresses in order to get access to my server. So I'm going to show you how to do that. So I'm going to jump over to my VPC, and this is the demo VPC that I've created here, and I'm going to allocate 2 elastic IP addresses. So I'm going to click on allocate elastic IP address, and I have a couple of options here, where the first is I can choose from Amazon's pool of IPv4 addresses. You could also bring your own IP address. So you can imagine if you're migrating an existing server that you have today, you want to be able to bring that IP address over so there's no changes required to your existing customers. In this case, I don't have an IP address that I want to use, so I'm just going to use one from Amazon's pool, and I'll click allocate. And you can see here I got this IP address that is publicly accessible. I'm going to allocate one more because if you remember, I had 2 subnets within my VPC, so I need an IP address for each one of those. I'll click allocate, and we'll remove the filter, and you can see that I've got 2 IP addresses allocated within my VPC that I'm now going to use on the transfer side. So I'll come back to this. We'll do a refresh, and back here, select this. Okay, so now to configure my access to my VPC, I'm going to select which subnets I want to access from. And I've got, remember, 2 subnets. So I'm going to select my subnet ID for US West 1B and my subnet for US West 1C. These are availability zones within the Northern California region. And then I'm going to select which elastic IP address I want to allocate to each one of these. So you recognize these from the previous steps. So I'll choose this one for the first subnet, and I'll check this one for the second subnet. It doesn't really matter which one you use for which subnet, but now I've got my 2 allocated. So my VPC configuration is up and running now. So I'll click next. And then it's going to ask some additional questions about how I want to configure logging. As Smith mentioned, AWS Transfer Family will log access as users log in, log out to the system. A bunch of other things will log that into CloudWatch. And AWS Transfer can create the role necessary for the service to be able to talk to CloudWatch. So I'm going to let it go ahead and do that. Another part of seamless migration may be bringing over your server host keys. We allow you to do that here. Again, I don't have a host key, so I'm going to ignore that step. You could apply a tag if you wanted to. I'll click next, review everything. So I'm going to be using the SFTP protocol. I'm using Service Managed Identity Provider. I'm using a VPC endpoint type. You can see my 2 subnets that I'll be using, and then it's going to auto-generate a role for me. And I'm going to go ahead and click Create Server. And so that's going to take a few minutes to generate that server. And while we're doing that, I'm going to turn it over to Smitha to talk a little bit about the difference between service managed identity providers and custom identity providers.
Thanks, Jeff. So as Jeff mentioned, we have 2 ways you can store and manage your end users. The first one is what we call service managed authentication. In this case, you store and manage user identities and SSH keys inside the service. The way it works is first you configure your users, right? And as a part of that configuration, you provide the username, their SSH key, the IAM role, and the logical directory mappings that you want to use for their access. And once you configure your users, the next step is when your users log in, we look up their credentials within our service, and we assume the IAM role to service their file transfers. So that's the one that Jeff is using as a part of his demo. In the next form of authentication that we call bring your own authentication, that's where you can integrate an existing identity provider. Right? So if you're using Okta, or if you're using Microsoft AD, or if you're using DynamoDB, this gives you a way to continue to use that same identity database while you use our service for the file transfers. The way this works is there are a few steps involved when you set up this type of authentication. So first, you'd have to set up an API gateway endpoint and Lambda function that will have instructions on how to look up your identity provider, right? And then once you have that, the next step would be you need to integrate. So when you create your server, very similar to the steps that Jeff highlighted, when you select custom authentication, you'll get a prompt to enter your API gateway endpoint. That ties up the server with the API gateway endpoint so that in step 3, now your end users log in using their clients. We use that endpoint to look up your identity provider in real time and get the information back on whether the user has been successfully authenticated or not. And if they're successfully authenticated, that API gateway and function returns access information. Again, very similar to Service Manage, the same information that we use to service their file transfers to and from your Amazon S3 bucket. So with that, let's take a look at Jeff's demo, continue on there to see the server that he's created.
Awesome, thanks, Mitha. So let's head back and see. You can see that our server has been created. I'm gonna click on it and view a little bit of the details here. So you can see that a DNS name was created for my server automatically by the service. Again, if I had chosen a host name that I had brought in, it would use that instead. You can also see a few details here about the endpoint configuration. So you can see our 2 public IP addresses here. Those are the elastic IPs that we allocated earlier. They've been assigned and allocated to this particular endpoint. And we also have 2 private IP addresses here. So the nice thing about VPC endpoints is they offer you the flexibility, again, of accessing either publicly or internally. So if I had some internal processes that I wanted to provide only private access to, I could have them access directly via these private IP4 addresses. Now, if I grab this endpoint here and I go to my command line and I run the DNS Lookup command on that server, you can see that what AWS Transfer has done is it's created a DNS entry for this server name with these IP addresses. That gives us an extra capability for availability of the service. So the next step now is I want to be able to provide access to my users. Right now, there are no users who have access to my server. So I want to start out and I want to create my first user, James. If you remember with James, we wanted him to be able to log in and be locked down only to that folder in the S3 bucket, that James folder. So let me show you how to do that. So we're going to start by clicking Add User. I'm going to give the user's name James. And then the next step is that I need to select a role, an IAM role. And this role will be assumed by the transfer service to dictate the kind of rights that James has to the S3 bucket itself. So I created my role earlier. I'm going to select that one. I could also provide a additional scope down policy if I wanted to, but I'm not going to do that. And what I want to do is when James logs in, I want him to go specifically to my bucket. So that's my JP NCAL demo bucket I showed you earlier. And I want him going only to the James folder. And I'm going to check this restricted box, which means that when James logs in, he is restricted to only that folder or subfolders within that location. He can't go out of that. And then the service managed authentication uses keys for authentication. So I need to provide a public key for my user James. So I'm going to go back to my command line and I'm going to just cat my /demo, a key that I created earlier. And we're going to grab that and I'm going to copy that and I'm going to paste it into here. And that's all I need to do. And I'll click Add. And you can now see that I've got my user James. So now what I'm going to do is I'm going to hop over to CyberDuck and I'm going to attempt to log in as James to my server. So I'm going to grab my endpoint name here and I'm going to head over to CyberDuck here, which is again our common SFTP client. So I'm going to click Open Connection. I'm going to paste my server in there. My username is James and I want to use my demo key here. And I'm going to click connect. Now you'll see down here what's happening is that this is just spinning. Nothing's happening. So something's not quite configured correctly yet. If you remember when I showed you earlier, we need, there's a security group that gets configured around the VPC endpoint. Right now, that security group is configured only for access within the VPC. We need to be able to update that. So what I'm going to do is I'm going to click, actually I'm going to go to my VPC console here, and I'm going to click on my endpoints. And you can see here that I have a service endpoint for transfer that was created by the service. And I've got my security group here, which I need to modify to give access to my laptop. So I'm going to click on this. And if we look at the inbound rules, you can see that it's only allowing traffic within the security group itself. I need to allow access from the internet from my laptop. So we're going to edit inbound rules. So what I'm going to do is I've already got this rule in here. I'm going to add a new rule. It's going to give me access from my laptop. So we're going to, so SFTP uses the SSH protocol, which is port 22. So we'll add that there. And I want to use my IP address, my current IP address today. And we're good. So that should give me access. So I'm going to click Save Rules. It's now applied that rule to my security group. And let me go back to CyberDuck. You can see it's still spinning here, but in just a second, it's going to be able to get access to my transfer server. So this is a new server. My CyberDuck client doesn't recognize the fingerprint yet, so I'm going to say, yeah, just go ahead and trust that, and we'll allow it. And it's authenticating using my key, and it logs in. Okay, now we're logged in, and we're looking at my S3 bucket. Now, right now, there's not anything in that James folder, so I'm just going to do a quick upload of a file I pre-created called demofile.txt. It's just a small little file. We're going to drop it into there. And I'm going to go back to my S3 bucket. And I'm going to click into James folder. And you can see my file is now in S3. I uploaded it on my laptop via CyberDuck. It got transferred to the transfer server, and it got dropped into my bucket. Now, it works in both directions, because what I can also do is I can create a folder in here. We'll just call it folder 1, hit save. And then if I go back to CyberDuck and if I refresh, you can see that folder 1's now been created in there. So not only can I put files into S3, but I can also see changes that have happened on the S3 side. Okay, so James is working as we intended. Now we need to go ahead and add our second user, John. So let me head back to the console. And we're going to go ahead and create another user. But in this time, because I want to give John access to multiple folders in a different way, I'm going to need to do this from the command line. So let me switch over to my command line, and I've gone and I've created a script called create role. And in this script, what it's going to do is it's going to call two CLI commands. It's going to call AWS Transfer create user, and it's going to call AWS Transfer import public key. So this first one, the reason I'm using the command line is because I want to create what are called a logical directory type for my user, John. And what that means is that it's going to have two mappings in it. You can see mapping 1 and mapping 2, which come up to here. So I'm going to create two types of mappings. The first one is going to be a folder called John. So that means when John logs in, he's going to see a folder named John, and that's going to point to my John folder in my bucket. There's also going to be a second folder called John Temp in uppercase letters like this, and it's going to point to that temp folder. You notice that I don't need to name that entry the same as the folder itself. I can be very flexible in how I assign names to these locations. Again, this gives us an added level of flexibility to provide access to users to specific folders. So what I'm going to do is I'm going to go ahead and I'm going to grab my server ID here, and I'm going to call create role. Pass it my server ID, and it's going to go ahead and create my user John, and then it's going to upload my public key. I'm using the same key that I used for James. Now, so that's been created, and if I refresh my page here, we can see that we now have got a second user named John. And if I click on John, and if I view his home directory, I can see those two entries in there. for the 2 folders that I created. So now what I'm going to do is I'm going to go back and I'm going to disconnect as James, and now I'm going to connect as John. So it's the same server, just a different username, same key. I'll click connect. It's authenticating. And now we see those 2 top level folders, one for John and one for John Temp. Again, works the same way as James. I could go in here and I could drop a folder anywhere, but rather than locking John into a single directory like we did for James, now we've broadened it up a little bit. We've opened it up and allowed him access to more data within our bucket. Okay, so what we've done is we've showed you how you can set up a transfer server, how you can create users using service managed authentication, and how you can provide access to your S3 bucket for users in different ways, using either standard directory access or using logical directory access. So with that, I'm going to go ahead and turn it back over to Smitha, and she's going to wrap it up for us.
Thanks, Jeff. So to do a recap of what we talked about today and the demo that Jeff gave on how you can seamlessly migrate your users so that, as you're migrating from your on-prem or do-it-yourself setup to the cloud, your users are not disrupted in any way during this migration. If you want to continue to use the protocols that you are using, you can now enable SFTP, FTPS, and/or FTP on your endpoint. If you want to continue to use the same credentials for your end users, you can, as you saw in the earlier slide, you can integrate your existing identity management systems. If you wanted to keep some of the firewall configuration same on your end user side, Elastic IP that Jeff demoed gives you a way to keep that IP address on your endpoint static. If your users have scripts that they're using to access your data, what you saw with the logical directory mappings gives you more flexibility on how you want to present some of those folders to your end users as they log in and access your data. And if you wanted to present your server's identity the same as you did when it was on-prem, you have the choice to use your own host key from your existing server or even bring your own TLS certificates for your FTPS server. With these features, you would have now migrated, and now with the data in S3, you have multiple options on how you want to build your downstream processing engines for analysis. I'd like to point you to a few resources that we have that will help you get up and running using our service. Some of the blog posts that we've published recently go deeper into a few of the use cases that are commonly used by our customers. Notably, the FTPS and FTP will help you get started in setting up servers that are enabled for these protocols. We also have a few workshops where you can download templates and get started easily in setting up your server and your users and your security groups, as Jeff did his demo earlier. We have a couple of videos. One of the videos is a demo of using all 3 protocols on the same server, and we have an overall overview demo if you want to look into some of the benefits the service provides. And we'd like to thank you for visiting our webinar today.